Good morning, students. We are discussing chapter mineral nutrition, right? Yesterday we discussed some important points in a note. Write the next point in note, right? Listen, molybdenum is the essential element which is required in minimum quantities for growth and development of the plant. Therefore, which essential element is required in minimum quantities for growth and development of the plants are molybdenum. Molybdenum is the essential element which is required in minimum quantities for growth and development of the plant. What it is? Molybdenum. Okay, right? Now, see these statements. Sir, essential elements they are absorbed in which form? Essential elements they are absorbed in which form? For example, this chart is important, therefore be careful with this chart. Go for the first one. What's our nitrogen? Sir, nitrogen is mostly absorbed as a NO3 minus. Sir, NO3 minus monovalent, what it is? Monovalent anion, right? Sir, sometimes nitrogen is absorbed in NO2 minus form or NH4 plus form. NO2 minus monovalent anion, NH4 plus monovalent cation. Okay, it means plant is absorbing nitrogen mostly NO3 minus form. In sometimes it is absorbing as NO2 minus or NH4 plus. It means nitrogen is absorbed right in monovalent form, either as a anion or as a cation. Therefore, absorbed as a monovalent ion, either as an anion or as a cation. Okay, go for the second one. What's phosphorus? Sir, this phosphorus is absorbed by the plant in the form of phosphate ion. Which ion, sir? Phosphate ion. What it is? H2PO4 minus. H2PO4 minus, right? Monovalent what? Anion. Or HPO4 minus 2 divalent anion. Therefore, plant is absorbing phosphorus. Plant is absorbing phosphorus in the form of phosphate ion. Phosphate ion, which is anion or cations are anion. It may be either monovalent anion or divalent anion. See here, absorbed as anion, either as a monovalent anion or as a divalent anion. Okay, go for the next one. What's our potassium? Plant absorbs this potassium as a potassium ion, that is a K plus. Anion, cation, monovalent cation. Okay, now go for the next one. What's our calcium? Plant is absorbing this calcium in the form of calcium ion, that is a Ca plus 2, Ca plus 2, right? Sir, plus cation, plus 2 divalent. Therefore, plant is absorbing calcium in the form of a divalent cation, right? Go for magnesium. Sir, plant is absorbing magnesium as Mg plus 2, magnesium ion, Mg plus 2, magnesium ion, right? Plus cation, 2 divalent. Therefore, plant absorbs magnesium as a divalent cation, Now go for next one, sulfur. Plant is absorbing sulfur in the form of sulfate ion. Which ion, sir? Sulfate ion, that is SO4 minus 2, SO4 minus 2 minus anion, 2 divalent. Therefore, divalent cation, anion, divalent anion. Go for the next one. What's sir? Iron. Plant is absorbing this iron in the form of ferric ion. In the form of what? Ferric ion, that is Fe plus 3 plus cation, 3 trivalent. Therefore, plant absorbs iron in which ion form, sir? Ferric ion form. This is important. Ferric ion form. Okay, that is Fe plus 3. Therefore, trivalent cation, right? Now, go for manganese. Plant absorbs manganese as a manganese ion. Plant absorbs manganese as a manganese ion, that is Mn, right? Mn plus 2. Sir, plus cation 2 divalent, therefore divalent cation, divalent cation. Sir, zinc. Plant absorbs zinc in the form of Zn plus 2, Zn plus 2 plus cation 2 divalent, therefore divalent cation, divalent cation. Go for copper. Plant absorbs copper as a cupric ion. Plant absorbs copper as cupric ion, that is a Cu plus 2, Cu plus 2 plus cation 2 divalent, divalent cation. Sir, boron. Plant absorbs boron as B4O7 minus 2 or BO3 minus 3. Okay, right? B4O7 minus 2, BO3 minus 3, minus minus anion. Sir, 2 divalent anion, 3 what it is, trivalent anion, minus 2 divalent anion, minus 3 trivalent anion, right? Now go for copper. Plant absorb, chlorine. Plant absorbs chlorine as chloride ion. Plant absorbs chlorine as a chloride ion, that is a Cl minus, Cl minus minus anion, monovalent anion, monovalent anion. Go for the last one, molybdenum. Molybdenum. Plant absorbs molybdenum as a molybdate ion. As what ion, sir? Molybdate ion, molybdate ion, that is a MoO2 plus 2. Sir, plus 2, what it is, sir? Plus 2, plus 2, right? It is divalent cation. What it is, sir? Divalent cation, divalent cation, right? Now see here. So take a nitrogen. What it is, sir? Nitrogen. Plant can absorb nitrogen, right, in cation form, anion form, right? It means plant can absorb nitrogen either in cation form or in anion form. Okay. Now you take a phosphorus. Plant absorbs phosphorus only in anion form, not in cation form. Okay, right. Now go for potassium. Plant absorbs potassium in which forms are cation form. Plant is absorbing potassium in cation form, not in anion form. Okay. Now go for calcium. Plant absorbs calcium, right, in which forms are cation form, not in anion form. Next, take magnesium. Plant is absorbing magnesium in cation form, not in anion form. Sir, take a sulfur. Sulfur. Plant absorbs sulfur as anion but not as cation. Okay. Now you go for iron. Plant absorbs iron as cation but not as a anion. Take a manganese. Plant is absorbing this manganese as a cation but not as a anion. Take a zinc. Plant absorbs zinc as cation but not as anion. Take copper. Plant absorbs copper as cation but not as a anion. Okay, right? Now go for boron. Sir, plant absorbs boron as anion but not as cation. Molybdenum. Plant absorbs molybdenum as cation but not as anion. Take chlorine. Plant absorbs chlorine as anion but not as cation. Is this statement okay? Therefore, if you take nitrogen, plant is absorbing this nitrogen either in cation form or in anion form. Is this statement okay? Right? Now we are going to discuss some important statements, right, concerned to essential elements. Okay, right. Number 1, go for the first one. Anion cation balance in the cell. Anion cation balance of the cell or in the cell. Okay, right? Sir, what's sir? Anion cation balance in the cell or of the cell, right? Sir, what are the essential elements involved in anion cation balance of the cell, sir? I am writing potassium and chlorine. What and what, sir? Potassium and chlorine. Sir, potassium is a macro element. Yes or no? whereas chlorine is a micro, it's a micro element, it's a micro element. Sir, this potassium chlorine along with sodium determines the solute concentration of the cell. Determines what, sir? Solute concentration of the cell. What? Potassium chlorine along with what, sir? Sodium. Sir, sodium is a beneficial element, yes or no? It is a beneficial, it is a beneficial element. Okay, therefore, sir, potassium chlorine along with sodium determines what, sir? Determines solute concentration, determines solute concentration of the cell. Determines what, sir? Solute concentration of the cell. Okay, right. Number 2, go for the second one. Photolysis of water, photolysis of water, photolysis of water. Sir, photo means light, lysis means breakdown. It means a breakdown of water in presence of light is called as photolysis of water. In photosynthesis topic, we will get this right, photolysis of water in detail. Okay, right. Now, photolysis of what, sir? Water. Sir, here I am taking one water molecule, one water molecule. When this one water molecule undergoes photolysis, it produces 2 electrons, 2 protons and half molecule of oxygen, half molecule of oxygen. Sir, can we call this half molecule of oxygen as right, one oxygen atom? Yes, one, what, sir? Oxygen, one oxygen atom, one oxygen atom. Okay, therefore when photolysis of water takes place, what is liberated? Oxygen is liberated. So photolysis of water is also called as oxygen, oxygen, what, sir? Oxygen evolving reaction. What it is called as? Oxygen evolving reaction, oxygen evolving reaction. Okay, which reaction, sir? Oxygen evolving reaction. Sir, in this photolysis of water, what is undergoing splitting, sir? Water. So it is also called as water splitting reaction. Which reaction, sir? Water splitting reaction. Therefore, photolysis of water, oxygen evolving reaction, or what, sir? Water splitting reaction. Sir, this photolysis of water requires one complex, requires one complex. What is that complex, sir? Requires a complex by name oxygen evolving complex. What is the full form of OEC, sir? OEC stands for oxygen evolving, oxygen evolving complex, oxygen evolving complex. This oxygen evolving complex is made up of what it is made up of, sir? It is made up of manganese, chlorine, calcium. Is this statement okay? Right. Sir, we are discussing photolysis of water. To carry out this photolysis of water, what is required? A complex is required by name oxygen evolving complex. This oxygen evolving complex is made up of manganese, chlorine and what, sir? Calcium. Sir, manganese and chlorine, these two are what, sir? Micro elements. These two are micro elements. Whereas calcium is a macro element. Calcium is a macro element. Therefore, oxygen evolving complex is made up of 2 types of micro elements and 1 type of macro element. 2 types of micro elements and 1 type of what, sir? Macro element. Okay, right. Go for the third one, right? Number 3. Number 3, right? Sir, redox reactions. Redox reactions. As chemistry students, you know well about these redox reactions. Nothing but oxidation reduction reactions, right? What's that? Oxidation reduction reactions. Oxidation reduction reactions. Oxidation reduction reactions. Okay, right. Sir, what are the essential elements that participates in this redox reactions? Essential elements that are participating in redox reactions. Okay, first one is iron. Sir, iron from which form to which form, sir? Fe plus 2 to Fe plus 3. Okay, right. Second example I am writing copper. What's there? Copper. Cu plus 2, Cu plus 2. Therefore, what are the essential elements that are participating in redox reactions, sir? What and what? Iron and copper. Sir, iron is a micro element, right? Copper is also a micro element, right? Iron from Fe plus 2 to Fe plus 3. Copper from Cu plus 2, Cu plus 2. Okay, Cu plus 2, Cu plus 2, right? Now go for the next one, right? Number 4. Sir, we are discussing about some important roles of essential elements, right? Go for magnesium. What did he say? Magnesium. Sir, magnesium acts as an activator of enzymes involved in photosynthesis and respiration process. Acts as a activator. Acts as activator of what? Enzymes. Enzymes involved in what's our photosynthesis. Enzymes involved in photosynthesis and respiration. Enzymes involved in photosynthesis and respiration, right? We are discussing magnesium, right? Sir, magnesium acts as an activator of enzymes involved in photosynthesis and respiration. Photosynthesis and respiration. Sir, magnesium is a central metal atom of chlorophyll. Central metal atom of chlorophyll, right? Who, sir? Magnesium. Central metal atom of what's our chlorophyll. Who is a central metal atom of chlorophyll, sir? Magnesium. Okay, sir, if you take magnesium in first year we read, sir, if you take magnesium, it is a central metal atom of what's our chlorophyll. Chlorophyll shows a tadpole structure with head and tail. What is that head called as? Porphyrin head. Sir, chlorophyll shows tadpole structure. Tadpole means with head and tail. That head of chlorophyll is called as porphyrin head. In the center of this porphyrin head, magnesium is present. Okay, therefore magnesium is present where, sir? Magnesium is present right in the center. Present where? Present in the center. Present in the center of what, sir? Porphyrin head of chlorophyll. Therefore, in chlorophyll, head is present, tail is present. Which part is having magnesium? Head is having magnesium. What is that head called as? Porphyrin head. This porphyrin head is also called as a tetrapyrolic head. What it is called as a tetrapyrolic head. In first year we read one statement, sir, this magnesium maintains the structure of ribosome. Magnesium maintains a structure of ribosome. Magnesium maintains a structure of ribosome. How, sir? If magnesium concentration is 0.001 m, then the two subunits of ribosome associates with one another. Therefore, if magnesium concentration is 0.001 m, right, two subunits, larger subunit, smaller subunit, yes or no? Two subunits of what? Ribosome. What happens? Associates. Sir, if magnesium concentration is less than, magnesium concentration is less than 0.001 m, then what happens, sir? The two subunits disassociates. The two subunits associates when magnesium concentration is 0.001 m, right? When magnesium concentration is less than 0.001 m, the two subunits of a ribosome gets disassociated. The two subunits of ribosome gets disassociated. Okay, right? Now go for the next one. What it is, sir? Go for manganese. What it is, sir? Manganese. Sir, manganese acts as an activator of many enzymes involved in photosynthesis, respiration and nitrogen metabolism. Okay, acts as an activator. Acts as an activator. Acts as an activator of many enzymes. Many enzymes involved in what, sir? Involved in photosynthesis, involved in photosynthesis, respiration, photosynthesis, respiration and nitrogen metabolism. What is nitrogen metabolism? Therefore, manganese acts as an activator of many enzymes that are involved in what, sir? Photosynthesis, respiration and what, sir? Nitrogen metabolism. Nitrogen metabolism, right? Deficiency of manganese. Deficiency of manganese. It means in a plant, if manganese is deficient, what it causes? Causes two diseases. Number one, marsh spot of pea. Second one is gray spot of oats. Okay. Deficiency of manganese. Deficiency of manganese causes what, sir? Marsh spot of pea. Next, gray spot of what, sir? Oats. Sir, deficiency of zinc. What it is, sir? Deficiency of zinc. If plant is deficient in zinc, right, what are the diseases that are caused? Okay, right? First one is Khaira. Khaira disease of paddy. What it is, sir? Khaira disease of paddy. Second one is little leaf disease. What is the second one, sir? Little leaf disease. Therefore, Khaira disease of paddy, little leaf disease, these are caused by the deficiency of what, sir? Zinc. Sir, deficiency of copper. Deficiency of what, sir? Copper. If copper is deficient in plant, what are the diseases that arises? Right, reclamination disease. Reclamination. Right, CLAMINATION. Reclamination of cereals or cereals and legume plants. Reclamination of cereals and which plants, sir? Legume plants. Okay, sir, take chlorophyll, sir. What, sir? Chlorophyll. Sir, what is the central metal atom in chlorophyll? Magnesium. Chlorophyll synthesis requires iron. Chlorophyll, right, synthesis. Chlorophyll synthesis requires what, sir? Iron. Iron is a micro or macro element, sir? It is a micro element. Sir, if chlorophyll is burnt, what is left? Magnesium is left. When chlorophyll burnt, right, what is left, sir? Magnesium is left. Sir, from where this magnesium came from, sir? Sir, magnesium is a central metal atom in chlorophyll. So when this chlorophyll is burnt, what is left? What is left, sir? Magnesium is left. What is left? Magnesium is left, right? Take IAA. What is the full form of IAA? Indole 3 acetic acid. Yes or no? Indole 3 acetic acid. Indole 3 acetic acid. Sir, for synthesis of IAA, synthesis of what, sir? IAA, zinc is required. For oxidation of IAA, for oxidation of what, sir? IAA, manganese is required. Therefore, synthesis of IAA required zinc. Oxidation of IAA requires what, sir? Manganese. Sir, zinc is a micro element. It is a micro element. Then what about manganese, sir? It is also a micro element. It is also a micro element. Okay, right?